Today I'm going to tell you more about which is the potential of LFAM, of large format additive manufacturing, and which are the things to bear in mind where you're looking at which parts of your production could be optimized thanks to LFAM. There are 6 major things that you can bear in mind in understanding if your part is suitable for this process or not. Of course, volumes of production, complexity of geometry, materials, technical requirements of the whole part, eventual technical advantages, and last but not least, the understanding of the supply chain and the need for logistics related to this part. First of all, production volumes. This is a technology that has been developed in order to produce on demand, just in time, with specific focus on very complex parts. If of course your production is a mass production with standardizing parts, it's most likely not suitable for this technology. If you're looking into producing parts on demand with slight changes in customization in small to medium batches, where the impact cost of your mold on the production of the part is very high, then that is a signal that LFAM might be the solution for you. Second, LFAM, especially through robotics, allows you to free up several other axes. You can tackle parts that are very complex geometries. When you're looking at parts that have organic shapes, specific geometries where mold making, for example, becomes very hard and difficult, LFAM might be more cost-effective and more suitable for that type of application. Of course, a critical aspect is analyzing the requirements that the material of these parts need to have. Based on a deep analysis, also thanks to our partners and thanks to our internal material lab, we are able to understand whether the requirements around the material of the part that you're having in your production can be substituted or suitable for several of the materials that we have qualified and characterized in our portfolio. The right choice of the material for the specifics of the application is critical in order to ensure the success of the implementation of these technologies. Additionally, it's very important to understand the compatibility of the single printed material with eventual post-processing required to complete the part. We know that this is very important, for example, in the marine industry as well as in the aerospace industry, where LFAM becomes one step within a supply chain where post-processing and integration of that with the right material becomes critical for the success of the application. Of course, when looking at your parts, the important thing to do is to do an in-depth analysis of your technical requirements of the part, which are the most typical things that we analyze in order to understand if a part is suitable for LFAM or not. Of course, dimensional tolerances, specific working temperatures of your materials, specific requirements of fire rating, as well as UV testing or other types of testing. All these requirements need to be mapped out, and based on the mapping that you're doing, you can understand whether this part can actually be suitable for LFAM or it's suitable for other processes. This process has several technical advantages, and when you're looking into printing monolithic parts, removing assembling, and removing the possibility of having human error in assembling these parts, as well as a lot of waste across the process, there might be a signal that LFAM is suitable. When talking about large parts, the scale, this is a process that of course focuses on parts that are over half a meter, and beyond 20, 25 meters. In many cases, you have several parts that are assembled and produced with traditional technologies and create an integrated part. It might be that you have some critical requirements that today, with your technical solutions, you're not fulfilling and you're not optimizing. Weight is a perfect example. Last but not least, it's very important and critical to understand which is the actual supply chain and the lead times required for these parts. If, for instance, these parts don't have very heavy logistics, that's another important signal that producing with LFAM, delocalizing production close to the point of use, and integrating thanks to a digital supply chain that these technologies allow would actually be a big benefit for a switching to this technology. Generally speaking, LFAM has a huge potential. And we have seen that and appreciate that in industries such as aerospace and transportation, automotive, marine industry, design, architecture, and construction. However, an in-depth analysis of all these elements together in order to understand which is the right application for it is critical to ensure the successful implementation of these technologies. That's why at Caracol we have always been application first. Thanks to our application engineering team, we support our customers every day in understanding and mapping the different potential benefits that they might have in implementing these technologies within their production. Therefore, what I would recommend to you, whether you're evaluating these technologies, find the right partner that can walk with you across the whole journey of understanding which are the right parts, developing and qualifying them, and eventually then internalize and scale your production.